Today in algebra, we're going to be working on graphing and solving inequalities. Now let's review just a little bit about what your inequality symbols are. We've looked at less than, is greater than, is less than or equal to, and is greater than or equal to. Those are your four inequality symbols. Let's take a look at how we graph those. If I have the statement x is greater than or equal to 1, how do I graph that on this number line? Okay, because of the equal to, it will be a closed dot on the 1, and I will shade everything to the right. And that would represent x is greater than or equal to 1. So anything, any number in this shaded area, could be like 1.5, 2, 2.53, 3 and a fourth, 5. Any number that I put in there that is in the shaded area should make the statement true. And does it? Let's try it. Is 2 greater than or equal to 1? It is. Let's try this next one. X is greater than 1. Okay, this time I don't want a closed dot. I want an open dot on 1 because I don't want to include 1, but I do want to shade everything to the right. So I could say that 2 is greater than 1, or 1 and 1/10 is greater than 1, but not 1 itself. It will not make it true. Okay, the next thing I want to just point out is what they call the set builder notation. Your textbook points this out, and this is called text set builder notation. It's just stating that x is greater than or equal to 1, and they state it as a solution. So if you're doing a problem and you get an answer of x and x is greater than or equal to 1, sometimes you might see it written as a set, x such that any number you put in for x will fall into this set. Okay, so then an overview of just graphing inequalities that we've done before is that you use an open circle if you have a less than or is greater than, and you use a closed dot if you have a less than or equal to or greater than or equal to. And then you shade accordingly. Now, one thing I do want to point out that in all these cases, your variable comes first. And I'm going to try to encourage you to rewrite your inequalities if they don't end up that way, to have it to where your variable always is first. And then it kind of helps you when you're shading, because a less than always points to the left. A greater than points to the right, and so forth. But the key here is an open dot is used for greater than or less than, and a solid dot is used for is less than or equal to, or is greater than or equal to. All right, let's talk about what we're going to be looking at then today. Let's solve an inequality. Now, the basic rule that we're going to find today is that in most cases, when you solve an inequality, you're going to solve it just like you did an equation. Okay, so if I had an equation x plus 2 equaled 5, how would I solve it? Okay, I'm going to subtract 2 from both sides. And I get x, and over here I get 3. But we're going to use an inequality symbol instead. X is less than or equal to 3. Now, anytime you solve an inequality, you always want to try to pick a number in this solution set and see if it makes it true. So pick a number that's less than or equal to 3. Let's try 2. Is 2 plus 2 less than or equal to 5? Well, 2 plus 2 is 4, and 4 is less than 5. So that is correct. Now, you do that just to double check your inequality symbol and make sure that you have it going the right direction. So we're going to put an open dot or closed dot on 3. Good, a closed dot. And what about the shading? Okay, we'll shade everything to the left. And don't forget to shade your arrow as well, because it shows it goes on and on and on. Now, I do want to, again, make a special note, if you want to write this in your handy-dandy notebook, to write your inequalities with the variable first. It'll just make it a little easier when you go to graph them. Okay, let's try another one. Solve and graph the solution to this inequality. Okay, when you think you have a solution, raise your hand, and I'll come around and check you, and then you can check your partner, please. All right, when you solve this one, I asked myself, what's being done to n? Well, it's being subtracted by 4, so we're going to add 4 to both sides. And I end up with 2 is greater than n. Now, in order to graph it, remember what I always tell you you wanted to have first. You want to have your variable first. So we're going to rewrite this as n. Now, is it going to be n is greater than 2, or is it n is less than 2? This statement said 2 is greater than n. So 2 is going to be the largest number. So when we rewrite it, we're going to say n is less than 2. Now, I always kind of think of it this way, that the inequality is pointing towards your variable in this case, so it's still going to point towards your variable, even when you switch them around. So then let's plot this. Let's graph it. We'll have an open dot or closed dot on 2. Okay, an open dot, and then a shade to the right or left. Good, to the left. Now let's pick a number and see if it makes it true. Let's do -3. -3 minus 4 is -7. Is -2 greater than -7? It sure is, so it worked. All right, try this one. Okay, what are you going to do to both sides? Everybody agrees we're going to divide by -2. And I'm left with x is less than or equal to a -7. Okay, let's pick a number that would meet that criteria. Give me a number less than a -7. You're at -7 here, so something less than might be -8. So let's plug that in. -2 times -8 gives you a positive 16. Is positive 16 less than 14? No. Uh-oh. Do we have a problem here? Well, no, what numbers would make it true? If we don't go this way, let's try something on this side of a -7. Let's do a -6. What's -2 times -6? A positive 12. Is 12 less or equal to 14? Yes. What do you think we have to do when we did something different here? We notice we divided by a negative number to solve. We're going to have to switch our sign. So you have x is greater than or equal to a -7 because you notice that we had everything shaded to the right, and any numbers here that we plug in will make it true. If I put a 10, 2 times 10 gives you a -20. Is -20 less than or equal to 14? Yes, it is. So the conclusion we can make that if you multiply or divide an inequality by a negative number, you must switch the sign, symbol. Switch or reverse the inequality symbol. Okay, now I want to make it clear though that it only happens if you have to multiply or divide both sides by a negative number. If I have a negative number involved anywhere else in the problem, as long as I didn't multiply or divide both sides by the negative number, I don't need to switch the sign. Let me see if I can give you another example in which that would be possible. Let's say I have 2x is less than or equal to a -14. Okay, to solve, we're going to divide both sides by 2. Now I get x is less than or equal to a -7. Now I did not divide both sides of my inequality by a negative number, so I shouldn't have to switch the sign. Let's see if that would make it still true. Give me a number less than -7, like -8. So 2 times -8 would be -16. Is -16 less than or equal to -14? Yes, it is. Okay, so because I did not divide both sides by a negative number, I don't invert or reverse the sign, the inequality sign. It stays as it is. Just because this number is a negative doesn't cause it to have to reverse. Okay, so then our conclusion then is that when we multiply and divide, it's a little different. You kind of have to watch for it. If you multiply or divide each side of an inequality by a negative number, you must reverse the inequality symbol. Kind of like a little warning bell going off in your head when you see that. Are you going to switch a sign? That's when that warning bell should go off, when you had to multiply or divide both sides by a negative number. Let's take a look at these examples. In this one, I'm going to divide both sides by 1/2 in order to solve. So would I switch the symbol? No. Okay, I would end up dividing by 1/2, which is the same as times 2/1, and I get x is greater than 6. This example, I'm going to divide both sides by 3, so I get x is less than or equal to 3. Do I need to switch the symbol? No, I did not multiply or divide by a negative number. Okay, here, I'm going to divide both sides by -1, or they say multiply by -1. Same thing, I get x, but this time I did multiply or divide by a negative number, so I have to reuse the reverse or opposite symbol. It would be x is greater than -4. And the last one, divide both sides by -2. So will I have to reverse my symbol? Yes. So I get x is greater than or equal to a -3. Okay, let's take a look at a word problem. This is a 1997, a software executive bid $19,550 for Superman's cape from the 1978 movie Superman. This was the highest bid. Okay, we're going to let B represent the amount of bid for the cape, okay, which was $19,550. Write an inequality for B. Now we know that $19,550 is involved in it somewhere. How does that relate to B? That was the highest bid. So this is greater than B. Okay, so 19,550 was greater than any other B that it had. Could it be equal to? No, it could have been equal to because that was actually the highest bid. So we want to include 19,550. Could I write it this way? That all bids were less than or equal to $19,550? Yes, you could write it that way as well. So if we're going to graph it, if they don't give you a graph, what I suggest you do is you put some numbers below it and above it, kind of your target number. Okay, so we know it's going to be about right in here, open or closed dot. Closed, and all the bids were less than or equal to that amount. So you've just graphed that inequality. Okay, let's try one more. You're going to define a variable, write an inequality, and solve for this statement. The difference of a number and 8 is no less than 12. Okay, give us a try. When you think you have it, raise your hand. I'll come check you. Difference. Difference means you're doing what? Subtracting. Okay, so I have a number and 8. Find the difference. N minus 8 is no less than 12. Okay, what does that mean? Does that mean this amount is not going to be greater than 12, or that's going to be greater than 12? It says the difference of a number and 8 is not less, basically, is no less than 12. It's not less than 12, so it has to be greater than. Okay, so the difference of a number and 8 is no less than 12. Well, could it be 12? If it's no less than 12, that means it could also be included in that. Okay, think about that for just a minute. So what do you think? The difference of a number and 8 is no less than 12. Would I have the equal sign under here as well? Yes, because it could be 12. It says it's not going to be any less than 12. So our final inequality is n minus 8 is greater than or equal to 12 to represent this statement. Okay, now we're going to solve. So will that number be? Well, I add 8 to both sides, and I get n is greater than or equal to 20. And then if they ask us to graph it, we could graph that as well. So my number has to be either 20 or larger. Okay, are there any questions? All right, today we worked on solving inequalities, and basically they're one-step inequalities. You work them just like equations, except when you multiply or divide by a negative number, you must reverse your inequality symbol.